and showing my screen now. Thank you for letting me know you cannot see the screen. Hopefully it's out there. Okay, great. We have an image and we have sound. So thank you, everybody. And so again, our focus is commercial duct tests. This will be kind of focused on how the Retrotec commercial duct tester, and we'll have a few different names or numbers that may come out there, but in general, this is the commercial version of the Retrotec duct tester. We're going to compare it to other duct testers in general and how it actually will comply with some of the requirements and or somewhat of the codes. I do make my intro a lot shorter and brief, but you should be able to hear me now. I've confirmed that there is sound, but we really like to get your feedback. So in the questions area, please make sure you fill in your information, your questions. I did have some questions that were sent to us early. I brought up some of those on a slide, but this is the one part that makes it very interactive and makes it a successful webinar is the more information you share with us. So here's what you have today. You have Colin Ginge in the background, and you hear my voice right now, Joe Medosh. So again, we appreciate everybody that's out there. And we can please confirm that you, if you're doing BPI credits and you did not sign them up, please make sure I get your name, email, and BPI ID number. Okay, so those are in there, and you really need to be paying attention in order to get your CEUs. Do not be the sleeping cat and kind of use this as a background information because you will not get your credits. A lot of stuff we'll talk about is on the retrotec.com site, so I recommend you go there, especially under the support page where you're going to find a lot of information from webinars to some of the manuals and other information you may be looking for. FAQs or other articles are all on that page. We do record these. In fact, we're recording this one, and we do edit them and post them on YouTube. Usually it takes about a week, maybe a little longer. But we want to let you know if you're looking for past webinars or you missed something about this webinar, it'll be posted up on YouTube. If you notice in your control panel, you have several handouts that you can actually just click and drag and add them to your desktop. So we included some of the manuals we'll be referring to on our webinar today that are right in your control panel. I can't stress this enough. This is the #1 issue when people call up for technical support. Please make sure you have the right firmware. You can check it on the pop-up screen in the beginning. The first screen on home shows it, or you can toggle through to the last page. You can actually find out what kind of firmware you have and your calibration cycle for your gauge. So that's a crucial element. So you must be 2.4 build 71B1. All right, without ado, we're going to kick in. We are recording, and let's dig into what we got here. So I do not have any polls, but what I would like to do instead of doing the official polls is just kind of get some information from the audience. What I'm looking for is, do you currently have a commercial duct tester? And if so, if you could let us know what that is. There's a variety of TSI, Oriflow. Some people actually use leaf blowers. So whatever it is you're using, that can help me a lot. So let us know if you have one or no, I don't. It is not our intention to make this a sales pitch, but it is trying to find out what people are adding or using. So we're going to explain why Retrotec has a commercial duct tester. In fact, maybe it's a good chance to do that right now. I'll speak for Colin to kind of go through that. And they a couple other manufacturers were engaging in conversations, and Colin said, well, we have an amazing gauge. Why don't you use our gauge with your commercial duct tester? And they were like, no, we're happy with the gauges we have now. And Colin was like, wow, you really missed out on a great opportunity. I'm going to go make my own commercial duct tester. And he did. And he made one that really puts a lot of others almost to shame in terms of its size and output and the flow that it can create for such a small device. It is mysterious when you look at it as to, wow, how can that compete? But actually it outcompetes. So we're going to explain to you why something smaller can actually produce more flow and create such high pressures. Colin, do you want to add anything to that story?
When you get into it later, I can talk about it.
Okay. So. All right. So the other question is that, are you doing any tests? So you may not have one, but you may borrow one. But if we're looking to find out, are you doing any commercial type of testing? And if so, then let us know if you're able to use some kind of guidance that we have here or something else that may be a little different. So here's our focus for today. We're going to talk about it's called the 400 series of commercial duct testers. You may hear the numbers 441, 442, 451 or 452. Those are just differential elements as to some of the components that your system may have, or whether or not it has the depressurization accessory, or if it's designed for a European system, or if your gauge is Wi-Fi or not. So the 1 at the end of those numbers means your gauge is non-Wi-Fi, or 2 means it is Wi-Fi, and the 5 means it depends on what type of accessories you may have. Again, we'll talk about, like I said before, why is this unit so powerful, and the ease of use, and we'll also talk about the testing requirements. And it's a different world in commercial than most people are used to in residential. So this is it. If you may not have seen it or gone online, I thought I'd give you some pictures to show. It looks very similar to the residential duct tester. In fact, it's in the same shell as the residential duct tester. So those are the kind of things that can be a little misleading, or thinking, not sure people know that this is a residential or commercial. There are some key indicators, one of which is the output on the side, the 2-inch flex that converts to a 4 there. That's the one indicator, as well as the back has kind of got a large belly on it. So here's some additional pictures to kind of give you an idea about what it looks like on all sides. It does use the same front plate and the same ranges as the residential duct tester. So there is some overlap. In fact, those same ranges are used in the blower door systems to go to the incredibly low flow. So let's keep moving through here. So it does come with everything you really need to do your testing. So it includes your custom case with the calibrated fan. It comes with all the ranges you need to do the majority of your tests, the flex duct. We include, Retrotec does an 8-inch plate to connect your flex onto your system. And I encourage you to maybe get a couple extra of those so you can actually set it up ahead of time and go through and do your test fairly quickly. All the tubing and everything you need is all contained in a separate little case that also holds your gauge. The first question we get commonly when we do this commercial system webinar is, can I just use a regular gauge to use commercial duct testing? Or the other one is, can I just use my commercial 20-inch gauge to do regular testing? So the first half of that answer is that this gauge is specific to this type of model because it actually tests at a potentially a much higher pressure level. So although many of us may be on the call that are residential and we live in Pascal, the commercial world lives in inches of water column. So this actually will go up to 20 inches of water column, and it's a special gauge that's designed to have those sensors inside of it. So you really couldn't or shouldn't use your residential gauge, which goes up to around 5 inches of water column, because you're going to be maxing it out or exceeding its ability to do those. On the same scale is that this one, which is geared towards the higher pressures, really wasn't intended to do lower pressures to read the residential fans also. So it is something that you need this specific gauge to do this specific type of test with this fan. So hopefully that answers some of the questions we normally would get. And again, I do want to stress that you do get all of the ranges that are all included, and they are incredibly simple to just literally pop out and snap in and take your next reading. There is nothing complicated to do that. You did get some great visual quick guides on how to use it for the gauge and the system itself to kind of guide you through how to do it and how to do actually a SMACNA test. And those manuals and these manuals are, again, they're in your control panel that you can just download right now. There's also a full-scale operational manual, and for those of you that use or want to use the software, which is incredibly intuitive and provides a great report, we included the manual on how to use that for Fantastic. Some people may be familiar that Fantastic does the blower door types of tests, but it also does several options for commercial duct testing. So here's kind of the scale or the weight. I got a couple of pictures to kind of like put that in perspective. So an average guy, average person can carry this from one floor to the other. Even with the whole case, it's only 35 pounds. But in general, it was designed to be something that was portable. You don't need anything as a wheel dolly or several people to carry it and put it on a truck or try and bring it up to the different floors. So again, this is kind of the scale that it's at. Everything does fit inside this nice case that we see Jay carrying here. And I tried to make this as in perspective as I could compared to some of the other comparable models that are out there. These are some of the questions that you guys had asked earlier in terms of when you registered. What are some of the certifications that are needed? I'll try and answer some of these now because they're not specific to the slide set that I have. unless you know of something, I don't know of a certification that is whether it's needed or required. I do know that there are several out there that, NEB has various requirements. Other ABAA or other air testing and balancing groups have them, but none that I know of that are actually a requirement or a code says you must be this type of certified in order to do these tests. Unless there's something that you're aware of, I'd be appreciated to let me know. Otherwise, it's very beneficial to be have certifications, but it's not something I know of that's required. Someone asked about the Retrotec versus the Panda, and I do have some slides that kind of compare some of those in terms of its max allowable test pressures. And one wants to know if this is specific to the 451, and it mostly is about how well this works. But in terms of understanding how the 451 works, you'll also understand how duct testing works in general. We do have some information about the Duct Blaster, and Cullen will comment on the fact that it really, like the residential version that Retrotec has, is not really intended or designed to do commercial type of testing. I will not be able to elaborate on the European standards, but I can tell you that they are included in the software. And what type of, again, certifications, we don't really know, but if you can help us with that, that'd be great. If you have any other questions, please throw them in the question box. We'll try and answer them if we can or get back with you, but they really help us a lot. So this is the number one question that we get when we're out there with this, either in the field or I'm demonstrating it or I'm at a conference, and that is that, so how much duct work will it measure, right? And there's a couple of things that are different, which we'll elaborate on again as the webinar goes through, but the Retrotec system allows you to do stuff that the residential world has been doing for quite a long time, and that is that I can extrapolate easily to the test pressure that I'm trying to test at, and also extrapolate to the area that I want my results in. So both of those requirements are built into the gauge, so I can really know instantly, even if I can't achieve a test pressure, I can know what my results would be at that test pressure, and I'll demonstrate that through a couple of slides. So according to what we have in terms of scientific comparison, there's some other versions that are out there that will do other duct testers that will do, let's just say, roughly over 6,100 square feet. This one will, the Retrotec will easily do over 7,000 square feet. Again, those things can vary on the test pressure or how the leakage class, but in general, those are pretty common numbers to compare to. We did actually compare the Overflow Cobra and Panda in terms of their CFM and to the Retrotec model. And the Retrotec model, I believe this is an 8 inches of water column. You can clearly see that this little duct tester keeps up with these larger monster types of duct testers. So we did want to give you some idea about where they compared, and also kind of comparison of the price for what you're getting. I have met several.
Hey, Joe?
Yes, Colin, thanks.
So I just wanted to make a comment there. This comparison is done at 4 inches. Now, when you go down to lower test pressures, both the Cobra and the Panda produce a little bit more flow than ours, but because we have the extrapolation feature, we can actually measure, in most cases, about 3 or 4 times as much area as, say, a Cobra can measure, and roughly about the same area as a Panda can measure, because a Panda uses a more accurate gauge. So there you go.
Great, thanks. Colin will be popping in every now and then to keep us straight on some of ours. In fact, Colin, why don't you just hang tight and help us with this one, because this is definitely something you live and breathe a little better than I do. Colin, you still there? We may have lost Colin. Oops, let's go back. So I'll help with the difference in MagnaHelix or even digital MagnaHelix is that they are challenged in terms of their readings or what they actually can truly represent, and they're based upon accuracy is based upon full scale. And so if you're not testing at 10 inches of water column, all right, then your accuracy is increased, right? So when you move down to 4 inches of water column, you become 2.5% of the reading. And at 1 inch of water column, it'll actually be 10% of the reading. The gauge that the Retrotec has is 1% for all readings full scale. So no matter what reading you're at, whatever inches of water column or test pressure you have, you're always actually getting the highest, most accurate reading, because it's only 1% of the reading, whether it's at 10 inches of water column or 4 or 1 inch of water column or less, you're always going to only be within 1% of your readings. The gauge, yes, Colin, go ahead.
Yeah, a translation for our European friends. I asked us to talk about pascals and meters squared and so on. I guess the easy conversion for meter squared is, we're saying 7,000 square feet. It's roughly about 700 square meters. And here, 4 inches of water column is 1,000 pascals, and 1 inch water column is 250 pascals. So back to you, Joe.
Okay. Oops, I keep advancing before I wanted to. Okay, so the other thing that the Retrotec gauge will do is, and I apologize that I don't speak European measurements very well. It's something that's on my list of stuff to learn. So we'll make a note to try to see if we can't convert this into something when we do that in the future. So I apologize for those challenges. So the one thing that the gauge will do, as I was trying to say, is it actually can do a great job of averaging your readings and reducing errors so that you don't get instantaneous readings. You actually can get something that's over 5, 10 seconds, even 20 seconds if you feel there's fluctuations or challenges in the ductwork itself. So, and Retrotec does have the only one that we're aware of, besides going to some of the European folks over there, as the calibration that's an ISO 17025 accredited lab. So this really means that the gauge and the fans are all getting read at a much higher level. The other one that is a challenge, which I believe I have on the next slide, is or has coming up about you have to zero the gauge on the magnet helix. So to kind of go through the accuracy, is you're actually going to, and it could be Oriflow. Many of the ones have very similar stages or steps, so it's not necessarily geared towards them, but it's geared towards the process. We use Oriflow as a simple example because many of the people we talked to had these devices. So you have to visually read the gauge, which you have already had to zero. Then you have to look up the value on a table, apply to a formula, and get the flow. And again, the orifices can be plus or minus 2%. Then you add the gauge accuracy at 2 inches of water column. So in general, you can have flows that are up of 9 CFM errors over 7%. So those are an additive issue of errors on top of other potential problems you may be reading. And again, also the challenging of going to a flow and calculating all of those. So for the Retrotec system, you simply enter the test pressure either on the gauge or jog it into place, or you can also enter it into the software. And there's no math, there's no calculations. The gauge displays results in less than 3% for all readings. So all these things are very obvious. You can read kind of through the slide. I don't have to read it to you, but these are some of the things that really make the difference, is whether or not how complicated my results are and how fast I can actually get some of these results. So again, I manually zero the gauge. I'm perform the test. I'm looking up on the flow table, divide by the area, versus actually all the things can be done either in the gauge or in the software automatically. So when you first turn on your gauge, one of the great things about it is that it keeps your settings from the last time you did a test. So if you're doing multiple tests that day, it keeps all your settings. I don't have to reinitialize it or add a bunch of information or reset it up. So it keeps track that I'm using inches of water column. It keeps track of whether I'm using CFM or CFM per 100 square feet. It keeps the device and the range in there. The only thing I need to do is make sure that I confirm if I didn't change the range or the orifice plug to do my test. So if I have that in place, then I'm good to go. So here's how simple we can do a test. We're actually going to hit set speed. You can easily start even at 1% because this is such a powerful fan that I can start at 1 and then I can slowly tap my way up until I reach the test pressure that I want to achieve. The channel A at the top here is the test pressure that I'm achieving. And these are actually my results that I have down here on the bottom half. I have the ability to turn on the add feature and make that go exactly to what I have. So here I have an older slide that's residential, but I can demonstrate that we can also make that also at 4 inches of water column and get my results directly on this second line based upon the inches of water column I have here. So here's some of the differences that make life a whole lot simpler, is that when I have turned on the add feature. So on the left, these are my actual readings that I'm getting from my reading of, say I couldn't achieve 4 inches. I can only get to 3.5, 3.6, and these are my results. But when I turn on the add feature, which is on the upper left of the gauge, it'll actually calculate and give me my results based on as if I really would have achieved the 4 inches of water column. So this is a phenomenal feature in terms of only being able to achieve a smaller test pressure in the system, but actually make sure I have the results even without that. So this is what allows the Retrotec system to expand beyond the other limitations from all systems. The other
So
method,
Joe,
yes, sure.
there's 2 points to be made there. One is that if you're trying to test at 4.000 inches of water, you're never going to be exactly there. You're going to be slightly above, slightly below, and so on. And even if you do an averaging and you do and you can measure it very accurately at 3.9 or something, then you have to make a correction back to 4. So this not only gets rid of that problem, but also does the flow measurement mathematically at exactly 4.0000 inches. So it actually does the math for you on an ongoing basis. So what you're reading is the gauge doing the math for you on a constant basis, so that the gauge, I guess, reading error, because every time you look at a gauge, 1 minute it's 3.9, it's 3.95, it's 4.05, etc. It's hard to get a gauge to read exactly 4.000. This does the math to give you the result at exactly 4.000. So that's the first point, which this more or less shows. The other one is, well, let's say that you have a really large duct system where it's exceptionally leaky, and you can get a very, very small test pressure. Let's say you can only get 0.2 inches of water. The accuracy of this gauge is 1% at any reading. So even at 0.2 inches, you can still get a very accurate result at what it would be at 4 or 8 or 10 or anything that you want, according to the SMACTA formula that you would normally apply. So anyway, back to you, Joe.
Great, thanks, Colin. Here's some comparison methods to either control the speed or to establish your test pressure. So on the left is actually a couple of options where you're sliding the gate. You've already adjusted the orifice. Or there's a control knob. There's a couple of different, more of a manual type of setups that you may have on the competition. Retrotec has a slew of pretty much options that can actually work in terms of something that may be more beneficial on how you decide to do your testing. So the first option is that the fan itself has a speed control knob on the DucTester, so you can use it versus actually using the gauge or software if I really just wanted to try and dial in what my test pressure was. Some people are more comfortable with that, and then after you get more familiar with it, then you can actually use the gauge itself, or you can also use the software that's on the next screen. So here, as I showed earlier, you can just use the set speed feature, where actually I just hit set speed and jog up the speed until I reach the test pressure or the max test pressure that I can achieve. And I can use the add features and all that. What also makes this feature nice on the gauge is that I can pull out my iPhone or Android phone and see what the actual reading is on the gauge. So the umbilicals come with the system, which is how I connect the gauge to the actual fan. They're about 7 feet. You could extend it, but if I'm going to put this system up on a scissors lift, I can actually control the units on the ground with my phone and see the readings. So I can actually see the readings that I have here that are occurring up on another place where I'm actually able to stop, start, and adjust all the same features on the gauge on my phone. So that's kind of an amazing bonus or a nice feature to be doing when you're in the field if you can't always be in front of your gauge. So the other one is a virtual gauge. That's also an app that will allow me to connect to one or even multiple fans, and that actually runs on a PC. The other ones, again, were a mobile app on your Android or Apple phones. The others we're going to talk about Fantastic, which is automatic software that can either manually or automatically run your SMACTA tests. So those are a common option for a lot of folks who are doing this and create a report. We did not. I didn't have the. I thought we did slide. So I did not have a chance to explain why. This is one of the questions, Colin. We didn't have a chance to fill in the answer, so that's why it says X, Y, Z. But can you explain why the Duct Blaster should not be used for commercial applications, or what are some of the challenges? And I do have the slide you're looking for next.
Okay. Well, why don't you put that slide on then?
Okay.
Yeah, and I'll talk about it. A few years ago, I had somebody call me, and they said they were using a Duct Blaster, and they they'd taken the ducts after up to 2 inches of water, and they're reading 800 CFM. I said it's totally impossible. So I discovered that if you take the duct blaster and you stall the flow, so there is no flow at all, which you see in the picture here, where the duct blaster actually taped to the floor, so obviously the flow through the duct blaster is zero. You can see if you look at the gauge that it's actually measuring 706 CFM, and it's creating a pressure down there of around 414 pascals or so. So there are people who will mistakenly think that their duct blaster is actually blowing a bunch of air into a duct, and but it really is designed only for 25, 50 pascals, 100 pascals absolute max, which is 0.4 inches of water, nowhere near the kind of pressures that we need to test commercial ducts. As a point of comparison here, our residential duct tester is 170 watts. Our commercial duct tester is 10 times the size. The motor is 1700 watts. So that's how much more power you need to blow that amount of air. So it blows half the air that our residential duct tester does, but it blows it at 20 times the pressure. So that requires a huge amount of power. A duct blaster will not work for commercial ducts. You might think it's working, but it's not. Back to you, Joe. Guess Joe must have taken a nap. I think your microphone's off.
I am off. I was trying to take a nap. Thanks for waking me, Colin. Are there any questions, Colin, that you read over that we want to address before I go to the next step here?
I'm listing a couple things. I don't have to. I'll just list them all off later, and no need at this point.
Well, I'm going to put you on soon because I had to. My PC forced me to restart, and so in order to bring up Virtual Gave Live, Fantastic Live, I need to switch over in a second. So if there's anything you want to grab now, that'd be great. But I see one real quick that I'll grab, and that is that someone asked, does the gauge require to be Wi-Fi? And it does not need to be Wi-Fi unless you're going to use it for the mobile apps. In fact, you don't need it to be Wi-Fi to even use it with the software that we have up here, Fantastic. That can all be done with a direct connection. So Wi-Fi is only an option if you want the convenience to read it on a mobile device. So I have some screenshots here of Fantastic automatic testing software. Again, you may be familiar with this as something that you use for your fan operations, or it's something that you or now understand you can also use it for duct testing. It also has a residential side and a commercial application. So there's several things that you're going to enter in terms of the class of the ductwork, the pressure, and a variety of features, and then we'll actually calculate it whether you do it automatically or in a manual type of a mode. These are the duct testing standards that are available for the duct testing side of the Fantastic software. So, oops, I thought I muted that stuff. So you can see what are some of the options that are out there. Again, there's a European, a France version, and 2 different residential versions depending on what type of compliance they actually test at, and a UK version there. This is just a bigger highlight of that. It also creates custom reports, which can really make your job or your company look incredibly professional by creating a report that's specific for a duct testing report. This actually has it's a different version for a slide for a blower door for this. So this is compliance with this standard. So your standard would show you the SMACNA standard you'd be working with. You can add your own logo. Add your own information about the building itself. So there's a variety of stuff that you can do to customize these reports. You can take out information that you felt is not needed, create a new template, and then it'll work off of that template in the future. So you have multiple options in terms of different types of reports that it can also generate for you. So this is a slide, and the secondary slide that kind of goes through Fantastic, that you can download Fantastic Lite. It's a free download from Retrotec.com. And for the first 30 days, it is free to do a whole lot of stuff. So it'll mostly do anything you want to do. And then after that, you can do Fantastic Lite, and that'll do 1 fan and 1 standard, your choice. So if you're going to purchase or keep Fantastic and use the Pro version, or the basic version, then you can make a purchase, and then you actually have the ability to run your SMACMA standards as part of that. And you can install it on multiple computers, so that you're not limited by one computer or only the boss's or the technician's computer, that multiple people can be running this exact same software, so that you're not limited by a single computer or uninstall and reinstalls. So these are some of the ways that it's used. So this is actually either using the virtual gauge or fantastic automatically on some of the job sites. I've gone around to a few places, and I have no reason to mislead anybody, but every place I've taken this to as a demonstration, they purchased this one that I brought. And the last 2 times I did it, they bought 2 additional duct testers. So it is something that people are totally surprised by how effective it is, how simple it is to use, and how it provides the results that they were using to lug around larger equipment. So virtual gauge is another different software option that you have that allows you to use a PC and see your results. If you're probably going to use a PC, you'd probably just be using Fantastic as your solution, because it actually will allow you to calculate your results directly from your input from the gauge, or run the test completely and automatically. And this is the gauge remote we talked about running off your phone, some of the options that are out there. So some other things we talked about earlier were comparisons, and that is how to change the plugs or the orifices. So there is no tools required. It actually changes in a matter of seconds. Some things have either tools or wing nuts or a variety of stuff, and can be a little cumbersome if you're not happy with flow that you have. And many of these ranges are somewhat overlapping, so that you're not always held tight by a single range. That usually it's they do some overlap, and then your gauge is going to tell you by having 2 dashes that you need to obviously alter your orifice, because I cannot get the results I need from the fan. So there's a couple of different ways you can either do pressurization or depressurization with the systems. So on the side is where the 4-inch flex goes into the 2-inch opening that's on the unit. And on the right, you can kind of see a typical setup and test that's out there. And so this is a pressurized test, right? And there is an adapter that you can use in order to do a depressurization test. So now I'm actually pulling air through the unit, and you can get this adapter. This adapter does work on this system specifically, but this is also something that is a larger version, larger opening that people use in residential also. It's also a common method that is a European testing process that's out there. And this is the adapter that's out there for depressurization for the 450, the 400 series commercial duct tester. So I'm going to go through the gauge on how to change your results and be familiar with. Some people may have the gauge already and they're familiar with it, but if not, you can understand what's the process and how to go from getting my results in CFM, which we kind of saw earlier. Well, one of the SMACMA results is actually you can get your results for CFM per 100 square feet of duct area. So it's a matter of actually tapping the channel B and going from CFM to CFM per 100 square feet. And there's a variety of options, so I'll go through them so that it may be familiar when you actually use the gauges. There's also, for the European group out there, there's European units, CFM per square foot. There's also liters squared per meter squared. And again, additional units based upon your region that you might be using. There's also CFM per 1,000 square foot, and we're back to CFM per 100 square feet. So as you see on the left, these are all of your optional units that you could use to confirm immediate compliance. So CFM still may be you thinking you need to do a calculation based on the amount of duct that you're actually testing. But again, the gauge can do all that automatically and give you the results instantly inside the gauge. You do want to make sure you're entering the area, because in order to do this calculation, it wants to know what's the area of the duct I'm testing. So in order to do that, you can tap the area, or I can tap the settings and enter the area. So we can go from 1,000 square feet and change it to something that's on this example is back to 1,000 square feet. But the goal was to show you how easy it is to alter your settings in the gauge. Now when I'm running my tests, I can actually get the results that I'm looking for. So I showed you earlier on how to use the add feature, and this is the same process that can be done as the add feature with the square footage applied. So I can be running a test, and again, maybe I only got to 0.5 inches of water column, and I can get the gauge to extrapolate on the right. So here I can actually turn on the add feature and get my area leakage per 100 square feet live in the gauge. And again, I've had all the other issues that may have been from either fan fluctuation or other pressure fluctuations to give me a solid result right there in the gauge that I can use for my documentation. I got a quick slide that kind of goes through commercial for those people that live in residential and are thinking about how commercial works. That uh, commercial lives in, again, inches of water column versus Pascal. So I thought I would just throw out some numbers so people could see that 25 pascals is 0.1 inches of water column. 500 pascals, which many residential people think is a high pressure, is only 2 inches of water column. And when we get to 2,000 pascals, we're still only approaching 8 inches of water column. So my goal is to try and put that in perspective for the residential viewers out there. One of the things that's very different about how residential versus commercial works, and that is that residential is about the square footage of the floor area served by that duct system. So if I had two duct systems, I would calculate the area of the house, and that area is what I would use to calculate the percentage for the duct leakage. Commercial is a completely different animal in terms of how it does it, and that your compliance comes from your engineer or the designer. That it isn't really exactly a code compliance, but how you perform your test and what your results will be are based upon what your engineer says how you should do your test. So a commercial is based upon the surface area of the ducts being tested. So you actually are going to calculate all the different sides. Sometimes there may only be one end cap, will be, depending on how you're going to do your test. There may be two end caps, depending on what it's connected to or what you've isolated. So, but again, you're going to figure out your surface area, and that's usually the leakage that you're looking for is what's your compliance path. So residential, we test the entire system at once, supply, return, air handler, whatever it's connected to it. But commercial, it's usually just a duct run. Sometimes it's only the supply run. Again, this can be determined by the engineer or the designer as to what only they want to do. Usually it does not include the branches or very far to the branches. It doesn't include the VAV valves or the variable air volume units that may be secondary conditioning. So the commercial concept is completely different from how we think about the residential, just test everything at once kind of a concept. There are separate standards for SMACTA on how to test the air handler by itself. So that way it's always isolated as a test, and we're only testing the main duct systems by themselves. Okay, so there are a couple of things that are code, and we have a couple examples of the code, but in general, we'll talk about the standards versus codes. So we're talking about low pressure here, which is less than or equal to around 2 inches of water column. That for most ICC or California Title 24, it's not a requirement to test these kinds of low pressures. And SMACNA doesn't really require it to be tested either. So it's only when you get up to 3 or higher that we're actually dealing with considered high pressure and whether or not you're going to test that. So for low pressure here, there are amendments in the ICC or Title 24 that give you guidance. If you're following SMACNA, it says your pressure is too low to bother with. Here, the code doesn't have exact compliance in terms of what it does, but it does refer to SMACNA standards, and I do have some references for the code references or the ASHRAE standards. So these are actually in the standards for ICC on how they actually refer to use the SMACNA method for if it's above 3 inches or more. So SMACNA is just kind of the standard or the accepted applied way of performing the test. There are other out there, but I don't think there's anything as well diverse or as popular, I guess is really the word is, on how to apply a testing standard. So here's a couple of different things that you're going to be aware of when you're trying to find out is what type of seal class. That's we're going to start by reading here. So I'm going to do a seal class, and a seal class also usually determines my test pressure. And so if I have a seal class of C, B, or A, I try to color code those, because if I come down below this section, then it tells me what it is I have to actually seal. So the sealing of these types of systems is based upon what you call the seal class, for obvious reasons. So I only have to do the transverse joints only, right? Here we also added the longitudinal seams and all the penetrations that go along with that. So C class is very leaky system, right? And it also tells you what my leakage class is based upon these columns that are moving straight up and down. So my leakage class is 16, and for rectangular or for metal. And we're going to go through a few scenarios to kind of like pick out what's very common. So if I had a seal class of A, and I was using metal ducts, then my leakage rate would be 4. All right. So these are all the things that are calculated with the software that you can use from Retrotec, or can easily be calculated and added to the. Sometimes you're given the results based upon either the air handler movement or what the SMACNA standards are. Many of the leakage class and the conditions can be looked up in the manual that is available, and you can download it from your control panel on how to find out what those are. So there are some specific. Oh, I have some testimonials. I try to move this to the end, but I'm going to just go ahead and throw them out now. So one of the people that was one of our main advocates as to why he loves this is because he had a different system, and he's in Hawaii, and he flies from island to island, and he has to take his unit apart until it becomes less than 50 pounds each, so he can take it on the plane with less of an impact fee. So he was tired of taking his unit apart, then reassembling it and doing that. So for him, he was thrilled that it fits inside of one case, and depends on who you fly, but he only had to pay a luggage fee of $25. So and he actually could carry it, throughout the airport. Was a great bonus for him. So he was thrilled with it, and gave us some pictures to use on what he liked. Some other people have used this and given us great feedback. There's most of the people that we work with have decided to buy more than one, so that they have either multiple locations or can perform multiple jobs on one site and move much faster throughout their requirements. Okay, so that one was out of line, but I went ahead and just finished it. So these are the requirements for the International Conservation Code. And again, the duct's designed to operate higher than 3 inches of water gauge water column. They're going to be insulated, and they follow a various of leakage. So this follows the leakage class and the formula that's on there. Again, all this is done automatically for you, so there's not a lot of time to spend on that. So ASHRAE has the standard to calculate the same conditions. They just actually use a different method on what it is you're giving and what it is you actually can calculate. All right,
Joe, I just wanted to make a comment there. So as of 2010, ASHRAE 90.1 required that at least 25% of the ducts were tested, unless if they're 3 inches or more, unless they were outdoors, in which case they have to be tested regardless of the operating pressure. And often in systems where they have ductwork on the roof, that ductwork has to be tested.
Do you have any other questions you want to answer? I want to try and bring up the software, but it's going to take a second for me to log into my other PC.
Do you want me to bring up the software in mine, or do you want to?
If you want, that's
fine. Along with it there?
Sure.
Okay.
We'll see who gets it up first. Put it that way.
Up first.
You got yours all up?
No.
Oh.
Oh, hang on. I actually have it up already. I just was trying to open it a second time, so I have it up.
Oh, okay. I'll make you the presenter 1 second.
It's on my right-hand screen.
That will be up to you to decide.
Oh, yes. Show my screen. Show my screen. Here we go. That one. That one. Okay, there we go. Can you see? There, you can see that. Hey, that's cool.
Great, huh?
Okay, there was a question, or someone was asking, how do I access the duct testing? So we go to Settings, um, Change Standard Used for New Tests, and another little window popped up over here, so we'll pull that over there. And you don't actually see it at first because it's kind of hiding down here, but we can pull this down and you can see we got so many of them there we actually have to scroll. So select the duct testing standard. In this case, we've selected SMACNA, but you'll see that we've got the European EN 12237, the French standard, residential duct testing standards, and the UK standard are currently in there. And there's an older version of the SMACNA in there as well. For those of you that haven't got the new copy of the standard, if you wanted to compare, there you go. So that's how you get there. And when you start the next test, it will start up as a SMACNA test or whatever you've selected, which in this case I've selected the SMACNA test. So you basically just kind of walk through from left to right, just like reading a book, and fill in all the blanks. Basically, you can either take the data when you're on the job site or do this on the job site. I'm thinking that most often people are probably going to be taking the data on the job site. And if that's the case, the two important things you have to make sure you get is what the test pressure should be. And even if you can't achieve it, you simply go to your gauge in Settings and you set the default test pressure or the default pressure to 4 inches if you're testing at 4 inches, 8 inches if you're testing at 8 inches. The cool thing about that is whenever you take a reading on your gauge, when you press the at key, you'll always get results at the test pressure you want, no matter what the actual pressure is. So you can take data and put it manually into the software, but let's say as you run through here, you see select the construction class the ducts being used, and we've got the size of the ducts. And over here we've got the seal class that we talked about already. And here we're going to put in the test pressure, which in this case might be 4 inches, let's say. Let's say we've got 4-inch ducts and so forth. And it automatically has put in the leakage class for the square and round ducts down here. So a lot of this stuff is all automated. And we've got this set on pressurization. So when you put a value in here for test pressure, let's see, I'm trying to think if you need to see this.
Let's put in the area for the ductwork over there first, over towards the left in the yellow, a little further down. You're getting warmer.
Oh, I see. Okay. Sorry.
No problem.
So it's 122, and we
leave
got a little bit
alone.
around there.
Okay, sure. Okay.
So here we've combined, square and round in this particular case. You'll also have a situation where you're going to be testing units in sections. And when you're testing in sections, here we'll just collapse this so you can see where things are going to go to next. If you want to test a section, you test it here, and then you can start a new set, which is right down below it here, and test another section. And then at the end, you can add them all up. So you could put 5, 10, 15 sections in there if you want to. It's very cool the way it does all the work for you. So let's see. In this case, for SMACNA, we're typically going to enter the data manually. For the UK standard, they require that you run it, I think, for 60 seconds. I'm not sure what it is. But the manual, which you can access incidentally by hitting Help, and you come down here to Fantastic for Duct Testing Manual, that will show you exactly what to do. You open that up, and that's the most recent version of the manual. So whenever you update your software, which you should do on a regular basis by going File, Check for Updates, you will get the latest version of the manual. Very cool. You just follow those steps. So let's say that we actually do a test here. We're going to enter some data manually.
Yes.
And we're going to put in our test pressure. Let's see, we got our 4 inches. And we have to select the unfortunately, I've got the wrong piece of equipment up here. I've got a 6,000 and we need to put in a 450, so we'll put in a 450. And we need to put in the 20-inch gauge. Okay, so now we've got that. And we're typically going to be, usually start out in range 47. And we're going to enter that data. Let's say that's 5 inches. And basically that's all you do. You put in the test pressure, you put in the pressure that's being read on your gauge as flow pressure. This will be channel A, channel B, very nicely outlined in the manual, and do a calculation. And basically we're done. So it's giving you a result here in CFM underscore feet for the in the exact format that SmackNet requires. I'm not an expert at SmackNet, although I have spent probably 25 hours trying to understand what the manual meant and going through it in infinite detail. So that's basically all there is. And then you go up here to.
Wait, don't leave just yet. 1 second, Colin. Do you mind? 1 second.
No, I'm not going to go yet. You go up here to generate report, and it generates report on that. Go ahead, Joe.
Yeah, so over there where you pick the range on the right-hand side, why don't you bring that drop down again, please? And scroll down, because you actually have options of actually telling what you're actually doing is trying to determine what the pressure was. No, bring it up again and scroll down. What my pressures were, or I actually see you actually have options of entering different CFM or different units. So you can actually select CFM. So this may come from your gauge, and now you can enter like say 15. Or we make it 13. Make it 13.
13 CFM?
Yeah. And now hit calculate. So what you're doing is you can actually either try and enter the pressure you had on the gauge based on that range, or I can actually get the CFM from my gauge. And you've noticed now we actually passed getting information directly from the gauge. And if you notice that right in the middle of the screen, I have this allowable flow rate that is telling me what my goal is to shoot for.
Okay, so you know what you're measuring, you know what your allowed is, and you know how far off the mark you are.
That's right.
Okay. That's why you're a teacher, Joe, and I'm not.
Well, I actually called technical support just before the webinar. How about
that? Okay, all right.
Are there any other questions that are out there that we didn't address, or something you want to make sure we're touching on?
There are a few questions in there, but while people are dreaming up new questions, I'll just kind of throw a couple of things out there that I ran across. Shoot, what are they? Oh yeah, just in no particular order. In the model 441 versus 451, the 4 stands for testing only in the pressurization direction. The 5 in 451 means you can test in either direction, and you get that little attachment that goes over the front of the fan. So just wanted to
can I clarify that? So if you have a 441, you can still buy the attachment and use it as a 451. So just because you may have bought a 441 doesn't limit you to buy the attachment.
It's a relatively inexpensive add-on.
Okay, I'm good.
I think I covered all the points I had listed down here, oddly enough.
Well, somebody asked about can you use a blower door fan? Can you kind of, I know you answered it, but other people didn't see that. Can you kind of explain why they can't just use a blower door fan?
Blower doors kind of run out of poop at around about 100 pascals, 0.4 inches of water. Anything over that, they start to get extremely inaccurate. So you can't even get a measurement at 1 inch of water with, it's a wrong kind of blower. It's designed to blow a lot of air at low pressure. And here we're blowing very little air at high pressure. So it's the exact opposite. So here these are kind of like Formula One cars. And I guess you could say that blower doors are more like gravel trucks. They move huge volumes of air, so on. So the only exception to that is in our 3000, 6000 fan line, you can buy what's called a 4000 fan, which is a 6000 fan that runs backwards with with a reverse pitch blade, so they run in what we call the contour mode. You connect two of these fans together, and they will blow 5,000 CFM at 2 inches, but not much above 2 inches. So there are some very specialized commercial duct testing applications where you could use those, because nothing comes close to 5,000 CFM commercial duct testing. I think the biggest one out there is around 1,200 CFM, and it runs on like 250 volts, 3-phase or something. So that's a huge amount of flow, but in general, the answer to that question is no. The other thing I wanted to mention was that one of the guys at the NEB show was talking about attaching a whole bunch of flux ducts onto the duct system, and then go around the duct tester and just attach it to each flux duct in sequence. There's actually a much easier way to do that, and that's to buy this thing that we call a Lindab collar. It's a round 4-inch collar that you can screw onto the duct. You can leave it there permanently. It only sticks up about 2 inches max. And there's a cap that goes over that seals off 100%. You take off this cap, and that will fit directly onto the end of our duct tester, which has a 4-inch collar on it. The 4-inch collar goes onto the Lindab connector with these 2 rubber seals, and you can make your measurements. When you're done, you take it off, you put the cap back on. If you ever want to go back and make a measurement again, you can actually leave that collar on there permanently if you choose to do that. So I thought that was kind of a very interesting way to make that measurement. So our duct tester flex ends in, well, the equivalent of 100 millimeters or 4-inch collar. Anything will go into a 4-inch collar will fit, and we give you one Lindab collar and another device that's 8 inches by 8 inches that can be screwed or taped onto the duct. So you got 3 different ways of connecting to the duct to make it easy for you. Okay, so what other questions do we have there?
How about the second to the last from Jeff?
Okay, I see Jeff's last one.
Oh, third to last, right?
He's asking what, in what parts of the country, assuming he's meaning the U.S., I'm not sure, is this being done currently, and is there code driving these tests? We have a list of the states that are, currently have these ASHRAE 90.1 code requirements, and we can send you that list. So I'll get that together, and we'll have a follow-up email, and we can send it out to you, the list of different states that require that testing. The way this MACTA manual is currently written is it's up to the engineer. If he decides it's going to be tested, whether it's 0.5 inch or 4 inch or whatever operating pressure, then it gets tested. So, in fact, they don't even recommend that it be tested, and that's, I guess, a direct contradiction to what I've heard about the efficiency of systems. That one of the failings in a lot of commercial systems is that they've got a blower running and 25% of the air is leaking out before it gets there. That blower is running like overtime. It's oversupplying the units closest to the blower where the pressure is the greatest, and it's undersupplying the units at the end of the building. The same kind of problems we run into in houses. Plus, just the fact that that blower, even though the air is still circulating within the building, that blower may be running at 25% higher speed just to keep the sufficient airflow, is an energy penalty and tends to wear out the equipment. So for the cost of duct testing for the life of the building, it's peanuts compared to the cost of not doing it, really. So we'll be sending you everyone that list.
Jeff had the question, if we don't hit the test pressure and we use the add feature, what's the accuracy for, especially if you have results that are incredibly low, like your example was, what if I only reach 0.2 inches of water column and I'm trying to reach 6?
I was going to come up with a little table that would show you the expected accuracy at the extrapolation pressures and what it would be using convectional equipment and what it would be using ours. It doesn't seem like it's happening all that often. The prevalence of people buying one and then all of a sudden buying 2 or 3 is totally out of our experience. We've never seen that before. So clearly these things seem to be doing the job. But it is a good question, and yeah, you're right. You're always going to have ducts that are leakier than they're supposed to be, or a lot bigger ducts than you thought you were supposed to be testing. So I think that answering that question as to what the accuracy would be using the app feature compared to conventional methods, I think is a really good question. I think it's not an easy answer, but I would need to do it over the complete range of extrapolation to answer it completely.
Well, the other part of that is that the extrapolation feature that you have based your gauge on is an industry standard, not just something that Retrotec has internally created. That it is a common way of extrapolating. Correct?
Well, we're actually using the SMACNA formula for extrapolating, which is uses an oddball exponent, and we use the same thing. And we actually agree with their approach, and it actually works quite well. What you will notice when you're testing ducts, when you have the at feature on, like let's say your test pressure is 4 inches, which is pretty typical, then you start at the fan, you get up to 0.1, zero point 0.2 inches. You'll notice when the at feature is turned on that the result doesn't change a heck of a lot when you go from 0.2 all the way up to 4 inches. So when you use the equipment, watch that and you'll be surprised at how little the answer actually changes. Actually, you go up to the test pressure. I think one of the reasons why engineers think they want to go up to the actually operating pressure or the maximum pressure of the duct is they want to see if the duct's going to actually hold together. So it's not so much of whether it leaks, it's whether the thing holds together. So I think there's an assumption that when you put pressure on it, that somehow the duct will kind of pry itself open. It's not actually something that I've ever seen, but I guess it's theoretically possible.
Yeah, I'll answer one of
So
those. Oh, go ahead.
go ahead, Joe.
Yeah, Rich asks, so is commercial duct testing primarily for new construction or even retrofit situations, even when they have air handlers or VAV valves installed? And most people that we're working with are all new construction, or it's a rehab or remodel with new construction as part of that. I don't know of anybody who's trying to do existing leakage or any kind of sealing. The problem is that you really can't isolate the systems once they're already behind finished surfaces. And the other half is that one of which is for compliance. So I'm sure there's people out there that are doing things that deal with air leakage or finding problems that are causing condensation issues. So there's methods for existing. They may not just be compliance. They may just be sealing up leakage that's causing an issue.
So I just want to make a quick comment on that. CX Energy Aeroseal did a presentation on a school actually that had a duct system put in. The problem is when they design the duct systems, they often put them in such a way that you can't actually see the duct. It's kind of tucked away in some corner there, and you can't really get at it. Even if you tried to seal it, you couldn't. And this particular school, they were never able to get certain classrooms up to a decent temperature. All the students were sitting around in their coats every winter. And what they did is they went in there and they measured the duct leakage, and they found out it was roughly, I think, 10 or 15 times larger than it should have been for if it had passed code. And they used the aeroseal system to seal the duct, and I think they got like a 93% reduction on it there. Joe's quite right. It is difficult to get in there and seal existing ducts, but with a system that they have, they can actually do that. And interestingly enough, what they use to pressurize up their system is exactly the system that I described to David, which is a 6,000 fan in series with a 4,000 fan, and that's what they use to pressurize the ducts and actually measure the leakage of these massively leaky systems. So there is an opportunity there. Okay, got anything else there, Joe?
No, we did answer David's directly online, and that is people ask, well, what do you do when no matter what system you got, you can't achieve pressure or you can't even get anywhere with extrapolating? And that if whoever you're working with, if this is their first time doing a duct test and it's yours, you're both going to have a learning curve. Believe me. Most of the installers know that it's going to be tested, and they actually will already set sections up into chunks that they know will be tested. It's nobody assumes that you're going to come out and test an entire system. So if you're working with an installer that's not used to things being tested, you do want to make sure you give them some guidance as to how much. And usually it's several hundred feet of a linear main path that is tested. And if you're going to do, again, a variety of incredibly long or vertical sections or all of the branches, you're both going to be in trouble. You're going to find that you got to take things apart versus preparing them ahead of time to have been into manageable, testable chunks. That's all we got on here, and some excellent questions. We appreciate your feedback and all the information that's out there. And yeah, anybody near Atlanta? Anybody out there near Atlanta? I live in Atlanta, so I'm looking for somebody who's close. That I always like to find commercial duct systems that I can take it out and practice, because it's not something I can practice in my house with this system. So yeah.
Joe, I'm going to get a hold of AirSeal and see if they can give us a copy of the study. Do we have a day or two before we send the follow-up email out to all the attendees?
Yeah. In fact, usually the person who follows up on all that stuff is Jay, and he's actually on a honeymoon vacation. He'll be back on over the weekend. So we have until the weekend to kind of gather our forces and send this out. So everybody, you'll see a follow-up email probably first of the week. Next week, yeah.
Okay, great. Well, I really appreciate the questions that people have asked, because they kind of direct us towards what people need to know. So that's tremendous. So thank you very much for those who put out their questions.
All right, I'm going to call it a wrap. If you have any other questions, you're welcome to contact technical support or training at retrotec.com and send us your questions, and somebody will get back with you with an answer, and if we don't know it, we will find it. So.
And if you wind up being fortunate enough to buying one of our duct testers and you don't like it, I'm sure we can probably take it back if you didn't like it. But so far, everyone's loved the heck out of them. So I think that if you want to do commercial duct testing, it's the right tool for the job. Was that my commercial break? I guess it was. Okay. Bye.
All right, that's finally a wrap. Thanks, everybody. Have a great day.
Bye.